why nuclei cannot be arbitrarily large, right? Remember that there's two forces, right? You've got let's look at a helium nucleus, right? That's pretty simple. You've got two positive charges and then two neutrons, right? Two protons, two neutrons, basically an alpha particle, right? These guys are repelling each other. The Coulombic force, right, repels, is trying to rip them apart, right? Okay. But the strong nuclear force, which is much stronger in the case of this atom, right? Okay, the strong nuclear force is holding them together. Binds together, right? Okay. So that nuclei can exist, right? In fact, they can exist quite robustly if they're small. Okay, but what happens is that this guy has basically a strong nuclear force. I think it might even increase as you try to pull them apart. Like it's a weird thing, or maybe that's quarks that do that, right? Okay, but the strong nuclear force, even though it's strong, is very short range, right? And so the strong nuclear force is short range, and the Coulombic force is a long range force. So even though it's weaker, even though the Coulombic force is weaker in small atoms, right? The fact that the strong nuclear force is such a short range force means that by the time you get to a nucleus, it's gigantic, right? This part cannot exert a strong nuclear force on this part. So this part has to exert a strong nuclear force on this part, has to exert a strong nuclear force on this part, has to exert a strong nuclear force on this part, has to, by proxy, exert a strong nuclear force on this. Well, that makes the nucleus kind of blousy. I mean, this is why fast neutrons can go through a uranium nucleus, right? Is that it's very billowy and loosely bound, and it's more like an oil droplet or something like that. Okay. So this is a large nucleus, and with a large nucleus, it's too large. The strong nuclear force can't exert a force all the way across the nucleus. For sure, the helium nucleus, it can exert a force across this because it's so small. Okay, so there's a limit to the size, and at some point, and you can see that, right? There's going to be nuclei that just can't exist because they're just too large. The strong nuclear force can't exert a force across the atom. The atom just is too big. Now we think that if you look at the stable nuclei, they think that there might be little islands of stability out there, and by stability means that they can exist for 10 to the minus 12th seconds or something like that, right? But the trick is how do you create those nuclei to even study them? But yeah, all right, I got to go teach class.